Good morning, Miss.
Assalamu alaikum, girls. Good afternoon. How are you all? Did you hear me, girls?
Yes, Miss, you're fine.
Yes, Miss.
Okay. Now, I hope you have the note with you in front of you now. And how many of you have gone through the topics that I have discussed already with you yesterday? I hope you're studying at home, right, girls? Okay.
Good morning, Miss.
Yeah, good afternoon, girls. I hope you're studying at home, right, girls? Because as I told you that this syllabus is going to continue with you. You're not in the junior grades. You are
Good morning, Miss.
You are an IGCSE student, so you have to continue with whatever we're doing now to grade 9. Okay, so all of you take these classes and the notes that we are discussing and the topics all very seriously. Okay, now, okay, I can see the other students are joining, but then also I will start. If you remember, girls, yesterday I was doing latent heat with you. Do you remember that? Okay, and we discussed what is a latent heat and what is the unit of latent heat and latent heat of fusion. Okay. Just to recall a small amount, I want to discuss with you again what is a latent heat. Latent heat is the amount of heat needed to change the state of a substance rather than changing the temperature of that particular material. Okay, and this amount of heat is needed to change the state. It can be solid to liquid, it can be liquid to gas, or liquid to gas, gas to liquid, or solid to liquid, liquid to solid. So yesterday we discussed about the latent heat of fusion. That is the amount of thermal energy. Okay, Salmin, could you switch off your? Yes. Okay. Now, so I was discussing with you that how to go for the latent heat of fusion. As I discussed with you that the amount of thermal energy needed to change 1 kg of ice to become 1 kg of water will be known as the latent heat of fusion. Okay. I gave you an example with ice and water. It can be something else also, any other liquid, so solid to liquid. The most common example that we can have, that is nothing but the water. So with the water, we know that the solid form of water is ice. So we have to convert ice to water. And for that, the amount of thermal energy is needed will be known as the specific latent heat of fusion, because it is going from solid to liquid. Okay. Now, all of you go to that topic that I have there. I told you that measuring specific latent heat of fusion. And first I wrote N, means what actually we are doing it in this particular topic. We are going to find out the specific latent heat of fusion of ice. As I say that we have different materials, but I'm going to take the easiest example that we have around us, that is water. So it will be the finding the specific latent heat of fusion of ice. Okay. What are the apparatus that we are going to use over here? As I said before also in the specific heat capacity, we use some of the experiments where we use some of the apparatus, and you will find some of them are very common. Like we have electric heater, ice will be taking, and a funnel, beaker, stopwatch, and mass balance. Okay, all of them are kind of known to you, but I just want you to ask. I want to ask you something. I hope you know what is a funnel, girls, because we use that one in chemistry. You might have seen on chemistry book the diagram of a funnel as well. You can see here I have a diagram given to you. There also I have the funnel here. So what we are doing, we just took a funnel and a small beaker, and we have certain amount of ice with us, and then we have an electric heater. Okay. So what is our procedure and what will be the procedure that we are going to follow here? First, you just check what we are doing here. Okay. That is, take mass of the empty beaker, we'll give it a name M1. If we just look at it, there is a beaker below it. So we'll take a similar beaker, means a beaker will take which will be empty, and we'll take the mass of this particular beaker. Then ice at 0 degrees Celsius. Okay, that day also I told you girls yesterday that ice can have a temperature below 0 degree as well. But we'll be using the ice which can have or which is having a temperature of 0 degrees Celsius. Means it should have the melting point. It should have melting point at this moment. Okay, then what we did, we took ice at 0 degrees Celsius and it is kept in a funnel and an electric heater is dipped inside the ice. An electric heater, a small tiny electric heater, if we just look at my diagram, you will see that electric heater I dipped inside the ice. Okay, we didn't switch it on, you'll remember that. First we are going to place it on. The heater and the stopwatch is switched on together. Because why do we need to have that? Because we have to ensure that whatever time we are applying or in the heater, we should calculate the time. We call it the time taken for the heating process. So we need to measure the time as well. That is why we're going to switch on the heater and the stopwatch at the same time. Okay. Then the heater and the stopwatch is switched on together. Note the power P of the heater. Yesterday I told you that most of the heater do have power written on the top of it. So we are going to just note it down before dipping it in. Okay. Now, after some time, some of the ice melts to form water which runs down the funnel and collects in the beaker. As we say, the electric heater is going to provide heat and that heat will be absorbed by the ice and it will start melting. And when it is getting melted, the water will run through the beaker, through the funnel, and it will be collected in the beaker. So after a certain time, we'll switch off the heater and stopwatch together. Then measure the mass of the beaker with the water in, that is M2. Means the ice got melted. Some of the ice got melted and become water. They all got collected inside the beaker. And with that water in the beaker, we are going to measure. So the mass of the melted ice will become M. That is nothing but M2 minus M1. And what was M1 initially? I told you M1 was the mass of the empty beaker. And now M2 is the mass of the beaker with the water inside. Which water? The water which came out from the ice when it got melted. Right, first? Okay. Now, at the same time, when we switched off the stopwatch, we are going to note the time taken for this process. So the time taken for the process is noted from the stopwatch. Now come to the part of result. We already learned the equation before that whenever there is a heat transfer going on between the two substances, like here the heater was providing the heat and the ice was absorbing that heat or receiving that heat. So we'll write down heat loss equals to heat gain. What is the heat loss? That is by the heater. So the power of the heater is P. And the time it was switched on, that was T. So PT equals to M, that is the mass of the ice that is melted, multiplied by the latent heat. And as I told you yesterday, that latent heat is the heat needed to change the substance from one state to another. So here it was ice, now it became water. So this is the time where heat was given to it to change the state of the substance, but the temperature of the water will also become 0 degrees Celsius. Okay, guys? Now, I rewrote the equation making LF as the substance because that was our purpose to do the practical. So, LF equals PT divided by M. M is the mass of the water, the one which we got from melting the ice, and P is the power of the heater, T is the time taken for the process. Okay, so this is the whole procedure done and we got the result as well. Now, we are not sure whether our result will be accurate or there can be some percentage of error. How to know that, and if it is there, how to avoid that mistakes. We can do one thing like precaution. Number one, I wrote, while heating, immerse the heater completely in the ice. Immerse means dipping it. If you keep the heater a little bit higher position where it did not go inside the ice, then there is every chance some of the heat from the heater will be escaping to the surroundings. right there? So the heat will not be completely absorbed by the ice. So we have to ensure that we are dipping the heater completely inside the ice. Point number 2, use leggings to reduce heat absorbed from the surroundings. Okay. Now, where are we going to use the leggings? The leggings has to be on the top of the funnel, because the funnel side is exposed to the air, and definitely the temperature of air is not 0 degrees Celsius like the funnel. So there is every chance through this surface which is exposed to the air or to the surroundings, some of the heat will be absorbed from that position. So we are going to do one thing. We can put leggings over the funnel to reduce the thermal energy absorbed from the surrounding. We will not say here loss, because it is not heat loss happens whenever it's an hot object. But here it is the ice that we are using inside the funnel. So definitely the ice is having a temperature which is much lower than the surrounding. So there is a chance the ice or the funnel is going to absorb some thermal energy from the surrounding due to the surface area. So we are going to wrap it with some leggings. Okay. After that, guys, check, I wrote note. I gave you 2 points which are important for this particular topic. You know why? See, the first one I read and then I'll explain. But before that, girls, tell me, do you have any doubt regarding this whole procedure, result, or precaution? Anyone having any doubt? Mamita, Maria, Mafuza, did you understand my explanation? If you have any doubt, you can tell me before going to the note, because the note depends entirely on the procedure. Do you have any doubt?
No, miss.
Oh, very good. So let's proceed. In the note, we are saying, point number 1, after switching on the heater, wait until water starts to drip into the beaker before taking readings. Okay. Now, as I told you initially that I am going to take the ice which will be of 0 degrees Celsius. But we are actually not sure. Whenever we take some pieces of ice, we consider that it is having a temperature of 0 degrees. If it is not, then our calculation will be absolutely wrong. So what precaution we can take for that procedure? We can do one thing. After dipping the heater, you just wait until water starts dripping from it. When water starts dripping, definitely you will understand that the ice is at 0 degrees Celsius, because 0 degrees Celsius is the melting point of ice. Got it? Okay. So we wrote, because ice might not be at 0 degrees Celsius and should reach the melting point. And to test whether it reached the melting point, only one point we have, that is wait until the water starts dripping from the funnel. Now, for this type of procedure, what are we going to do? We just place any beaker at the bottom of this, or at the end of the funnel, and dip the heater inside. Just check whether the water starts dripping. The moment it starts dripping, you take the beaker out, and the original beaker, the one you are supposed to, you took the mass initially, place it under it, and then switch off the stop. After that, go to the whole procedure. So this small thing, small precaution you have to perform just to make sure that your ice became 0 degrees Celsius of ice. Okay. Now, these are the questions indicating in page 4. Now, the next point they say, use finely crushed ice rather than large pieces. They'll be asking you the question, why do you need to use small pieces of ice rather than taking a big piece of ice? They'll ask you, why do you need to do that? Or what is the benefit of using small pieces of ice rather than taking a big piece of ice? The benefit is that because if you take a big piece of ice, there is every chance that inside that big piece of ice, the ice might not be at 0 degrees Celsius, and it could be well below 0 degrees Celsius. On the surface, it might be 0 degree, the big piece that we took for this experiment, but inside it might be -2 or -3 degrees Celsius. So it will not be a good idea to take a big piece of ice. On the other hand, there's another important point, that is, when you take small pieces of ice, it actually increases the surface area, which will allow the ice to take more thermal energy from the heater and conduct the heat very quickly. So these are the points you have to learn, and these are the questions you'll be getting related to this particular topic, this experimental procedure. These are the points that you need to remember. Okay, guys, any doubt about these two notes that I gave you here? Hopefully you don't have any doubt, right, girls? If you have a doubt, you can ask me the question before I'm going to the specific latent heat of vaporization. Do you have any doubt, girls?
Miss, can you explain the procedure one more time?
The procedure, right? Okay. So let's go back. As I say, that we are going to take a funnel, and inside the funnel, we'll be taking some ice, small pieces of ice, which should be at 0 degrees Celsius. And we'll be taking a beaker, and when the beaker is completely empty and dry, we'll be taking the mass of this particular beaker and note it down somewhere. After that, we'll take the funnel, and inside the funnel, we'll be placing some small pieces of ice, and on the top, we're going to place the heater. Okay, and we're going to place the heater inside it. After placing the heater, we're going to switch on the heater along with the stopwatch. As I already made ensure that my ice is at 0 degrees Celsius. So we are going to apply the thermal energy or provide the thermal energy by switching on the heater, and to take the time you have to switch on the stopwatch as well. Okay, when these two are on, you have to wait there for a few minutes, and you know that heater is going to produce heat. That heat will be absorbed by the small pieces of ice, and they will start melting. And when they start melting, they will become water, and it will run through the funnel to the beaker and will be collected in the beaker. Once we collect it in the beaker, after a certain time, think about 2 minutes, 3 minutes, you have to wait there for the procedure. Then switch off the heater and the stopwatch together. Switch off the heater and the stopwatch together. After that, you are going to take the beaker where we have some water collected due to the ice which got melted during this heating process, and take the new mass of the beaker with the water in. After taking the mass of this one, we will be taking the mass of the ice that got melted. And how can we do that? We are going to do it M equals to M2 minus M1. M2 was the reading we found with the water in, the beaker with the water in. And M1 was the empty beaker. If you subtract them, you'll be getting the mass of the ice which got melted and become water, which was collected inside the beaker through the funnel. Okay. After that, we'll go for the equation. As we said earlier, that we have the equation heat loss equals to heat gain. And who's losing the heat here? Definitely our electric heater. And who's gaining the heat? Our all the small pieces of ice that we have taken there. They will get the thermal energy. They will receive the thermal energy and get melted. After that, we'll be using the equation P into T equals to MLF. This P was the power of the heater that we are using for this process, and T is the time at which the heater was switched on. Then we have MLF. M is the mass of the ice that got melted. LF is the symbol of the latent heat of fusion. And as we are finding out LF, we'll be rewriting the equation LF equals to PT over M. So this is the equation we are going to use and substitute the value that we have collected from the experiment and get the final result for the latent heat of fusion of ice. Okay, I think Maria, it's clear for you now?
Yes, Miss.
Fine. So let's go for our next topic. That was specific latent heat of vaporization. The one right now I was discussing, that was specific latent heat of fusion. Means that was a solid and it was turning into a liquid. This time we'll be doing the one.
Is sleeping.
Yes, Mahmuda, are you saying something? I couldn't understand you. Okay. Specific latent heat of vaporization. The specific latent heat of vaporization is the one I was telling you. It has to be from the liquid to the gas. So there's a change of state is going to happen from liquid to gas. And as I told you, the most common example we have, that is water. So we'll be taking 100 degrees Celsius of water, and that 100 degrees Celsius of water will turn into 100 degrees Celsius of vapor. To do this process, we need certain amount of thermal energy, which will be known as latent heat of vaporization. But I use the word here specific. It means that there has to be 1 kg of water. Specific means we are going to make the mass of the particular substance that we are using for this procedure should be of unit mass. So that is 1 kg. So let me go through the definition. The specific latent heat of vaporization of a liquid is the amount of heat needed to change unit mass of liquid to gas without changing the temperature. As I told you, everybody knows 100 degrees Celsius is the boiling point of water. So 100 degrees Celsius of water will turn into 100 degrees Celsius of vapor. See, 100 and 100 did not change, but water became a vapor. So this procedure will be known as the vaporization. Oh, if you look at the equation, the same equation that we have in for that latent heat of fusion, E equals to ml V. V is the suffix, and I told you this V stands for vaporization. Then LV equals to E by M. And if you just look at the unit, you can find it out yourself very easily because E is for energy and energy is joule. And as I told you, mass is kg, so joule per kg. I gave you an example. The specific latent heat of vaporization of water is 2260000 joule per kg. If I convert this one to standard form, then I can write it like this: 2.26 into 10 to the power 10 to the power 6 joule per kg. 2.26 into 10 to the power 6 joule per kg. Amount of thermal energy is needed to change 1 kg of water at 100 degrees Celsius to 1 kg of vapor at 100 degrees Celsius. Is it clear to you now, guys? As I told you before, temperature is not going to change. So first we have to reach 100 degrees Celsius of water because the water we find in our room temperature that will be around 20 to 22 degrees Celsius or 50 degrees Celsius. It depends on the particular time of the season. Means now it is not that hot, then it will be around 20 degrees Celsius of water. That one we have to provide heat and increase the temperature to 100 degrees Celsius. After that, we can consider this 100 degrees Celsius of water will become vapor of 100 degrees Celsius. So that time the heat we will be providing will be used to actually change the state of matter from liquid to gas. So girls, tell me now, do you have any doubt about understanding the latent heat of vaporization? Any doubt, girls?
No, miss.
Very good.
Miss,
Fine.
could you explain one more time, please?
Latent heat of vaporization.
Yes, miss.
As I told you that this latent heat of vaporization is the one where the amount of thermal energy which will be given to it will be used to make liquid to gas. So as I told you, we'll take the example of water. At 100 degrees Celsius, water starts boiling. At the same time, it will turn into water vapor at the same temperature. So at 100 degrees Celsius of water, if I provide more thermal energy, it will change itself into 100 degrees Celsius of vapor. For this, the amount of heat energy will be given to it will be known as the specific latent heat of vaporization. Now, as I gave you an example that 2.26 into 10 to the power 6 joule per kg thermal energy is needed to change 1 kg of water at 100 degrees Celsius. This temperature is very important to you. So you remember 100 degrees Celsius to become 1 kg of vapor at 100 degrees Celsius. Just because we brought 1 kg, the unit mass over here, excuse me, girls, it will become specific latent heat of vaporization. Okay, if it was not mentioned about 1 kg mass, then it will be just latent heat of vaporization. Okay. Now, how this latent heat of vaporization is related with the kinetic energy. Kinetic theory means how will I explain this latent heat of vaporization by using the kinetic theory conception. That is, we already know that here the change of state is from liquid to gas. So the liquid molecules are to overcome the intermolecular force of attraction and gain the freedom to move around as gas molecules. Okay, if you remember, when we discuss about the kinetic theory, we say that the liquid molecules are a bit far from each other. They can slide over each other, and they can change their position. They have weak intermolecular force. They have more intermolecular space. All these things we discussed. But in case of gas, we say they are further apart from each other. They can move randomly whenever they feel like. They have negligible intermolecular force and a huge intermolecular space. So the liquid, when you provide heat to a substance, that time they will start moving faster than before. And these faster than before, when they are moving, they will push each other out, and they will, at a certain point, they are going to overcome the intermolecular force that was working before when it was in liquid. When they overcome, they will set themselves free and then start moving randomly, just like a gas molecule, and change the state to gas. So we are saying latent heat increases the potential energy of the liquid molecules, but not their average kinetic energy. The liquid molecules becomes gas without changing the temperature. All the time we are saying this thing that the temperature should not change, or the temperature cannot change. It has to be the same, but only the state of matter has to change from one stage to the other stage. Okay. Now one more thing I need to tell you from here, that is, as we learned that this molecule, whenever you apply heat to any substance, the molecule will start moving faster. In case of liquid, definitely we'll say about moving. They'll start moving faster, they'll push each other apart from each other, as well as they will try to overcome the intermolecular force that they have within them. If they overcome that intermolecular force, then these molecules will turn into gas and they will start moving randomly all around. In that position, we can say that the liquid is turned into a gas, but without changing the temperature. Okay, guys? Fine. Now, I will go to the next another experimental procedure, and let me remind you, these questions, the one I discussed with you before about the latent heat of fusion, and the one I'm about to do, both comes in paper 4 for a 5 to 6 mark question. Sometimes they just ask you to explain the procedure. You have to draw the diagram, apparatus, procedure, result, precaution, all together. Sometimes we do have this type of questions in paper 6. There also you have to follow the same procedure of writing. First, you'll be writing the aim, apparatus, procedure, then result, means what is your conclusion there, and after that, definitely the precaution has to be there. Okay, so let's do it. The first thing that we're going to do is the aim. What are we going to do here? To measure the specific latent heat of vaporization of water. And as I told you before, we used ice to make water. Now we are taking water to become a water vapor, or to make it gas, means water vapor. Okay. What are the apparatus we need here? Beaker, electric heater, water, mass balance, stopwatch. Okay, fine. So what are we going to do? See, I wrote the procedure. Number 1, a beaker with some water in is placed on the top of the mass balance. An electric heater is placed inside the water. But you remember, this electric heater is not going to touch the bottom of the beaker. It will be hanging here. Of course, we can do it by a stand and a clamp. But in the diagram, we didn't show you. If it is needed, we can use that. Okay. Point number 2, electric heater is switched on and its power is noted. See, we switched on the electric heater and the power is noted. Definitely, without the power, how will I calculate the energy provided by the electric heater? Okay. When the water starts boiling, now let me remind you guys, the water that we took here, definitely that is from the tap from our laboratory. So the temperature of the water can be highest to 20 to 25 degrees Celsius. And after taking it, when you are applying the heater to heat it, the temperature will keep on rising. It has to go to a boiling temperature of 100 degrees Celsius. So I wrote it very clearly. When the water starts boiling vigorously, means you will see inside the water there will be some movement of the bubbles. That is called the vigorous movement. The stopwatch is switched on. See, when did I switch on the stopwatch? When the water starts boiling all through the liquid, means all through the liquid, the temperature of the water came up to 100 degrees Celsius. I am going to switch on the stopwatch, and that particular moment I'll be taking the mass M1 is noted from the mass balance. Means when it starts boiling vigorously, two things I have to do. First, I'll be taking the welcome back, girls. Join quickly. I was in the middle of an explanation. I want to do it. Yes, girls. Yes. I hope you can hear me. Still waiting. Okay, guys. So I was discussing with you that as the water will start boiling vigorously, we are going to start the stopwatch and we are going to check the reading that is shown by the mass balance. So these two things we have to do when the water starts boiling vigorously. Okay. And then we'll not switch off the heater, allow it to keep on going, means it will keep on the heating process and we'll just check what's happening. So after a certain time, as I told you that it can be 2 minutes, 3 minutes, 5 minutes, it's up to you. After some time, the stopwatch and the heater are switched off together and mass of the water is noted. Means after you switch off the heater and the stopwatch, you are going to note the reading from the mass balance immediately. Okay, fine. As it is done, now we'll be taking the time for the process is noted from the stopwatch because already we have switched off the stopwatch. So we'll be just taking the reading from there. Okay. Now we took two mass readings, right, guys? The one we took that was immediately after the water starts boiling vigorously. That point we took one. And lastly, when we switched off the heater, immediately we took the reading of the mass balance. So if you subtract them together, actually you'll be getting the water that got steam, that became gas molecule or that turned into gas in this whole procedure. So I wrote that the difference in the mass reading gives the mass of water changed to steam during the process. Okay, so we are going to write it. After that, result. As I already discussed many times before, that whenever we have this type of experimental procedure, we know that heat loss will be equal to the heat gain. So the heat loss will be power multiplied by the time because we are using this heating process or heating element or electric heater. So we have to use the electric heater. As we are using the electric heater, we'll be checking with the heat loss equals to heat gain. For that procedure, we'll write PT equals to mLV. T is the power and the T is the time taken for the procedure. You multiply and equals to mLV. So M is the mass of water which turned into steam, and LV is the one we are going to find out. So I rewrote the equation. LV equals to PT divided by M. Okay. Now we should have also some precaution for this particular procedure. Now here we kept a beaker on the top of the mass balance and we were heating it. The temperature of the water went up to or rises up to 100 degrees Celsius. But that time the room temperature is not 100 degrees Celsius. The room temperature will be around 15 to 20 degrees Celsius. So don't you think that some of the heat might get lost to the surroundings from the surface of the beaker? Of course, there's a chance. So how to stop that? We'll use leggings or insulation to reduce heat loss to the surroundings. And we're going to place the leggings around the beaker so that it should not come in touch with the surroundings or it should not be in transfer of heat to the surroundings. Okay, point number 2. While heating water, immerse the heater completely inside the water. So we have to ensure that when we are keeping the heater on the beaker inside the water, it should be well inside it. It cannot come a little bit up so that it might get lost to the surroundings. So these are the points we have to keep in our mind when we are performing this type of experiments. Okay, fine, guys. So inshallah, next week I'll be continuing this one and hopefully next week I'll be able to complete this chapter. this last lesson of us. This full physics, thermal physics chapter, I will be able to complete, inshallah, next week. Okay, so I want to take today's class attendance first. Okay, so those who are here, please say you are present. Amira, are you present? Yeah, I think so. Afsana Zaman, yes. And then Amina Akhtar, yeah, I can see he's here today. Amina, what happened to you, dear? Last few days you were absent. Amina, could you speak up? Amina? Okay, fine. I think she's not following my class properly. Asma, are you here? Yeah, I can see.
Yes, Miss.
Okay, fine. Are you studying at home?
Yes.
Good. Mafuza, Mazabi,
Yes, Miss.
Mamita, Maria, Nazia, Nazia, yeah, Nazia is here. Huh?
Yes, Miss.
Okay. No, Omnia, Samin, Samia, Safa, are you here? I think so. She's here. Okay, Sumaya, are you here, dear? Sumaya Alamgir?
Yes, Miss.
Saida Zahra, she wasn't there in my previous class. Is she here today? I can't see her. Tanzila, are you here? Tanzila, I saw her today. Girls, Tanzila is here, right? I can't see her. Okay. Tanzila, are you here?
Yes, Miss, she is.
Okay. Zara, I think I saw her. Okay. Now, Mahmouda, Jannatunur, is she here? I can't see her. Nabila, not here. Lagat, I saw her. Reen, then Sadia Islam, Sumaya Islam, Sarah Khan, I think you are here. Sarah Haider, are you there? Okay, let me see someone message me.
Sarah Haider is present, please.
Yes, actually. Shaima, are you there? Okay. Sumaya Riyad, Saida Ikra. Yes.
Yes,
Then
Miss.
Saida Samia, I think I saw her today. Okay. Shahanara, Sumaya Zahid, are you there? Sumaya Zahid? Hello? I can't see her. Is she present, girls? I'm not sure. I think she's not there. Sarah Zaman, I see her. Okay. Tasnuba Aman, are you there? Tasnuba.
Yes, Miss.
Then Tamanna. Tamanna. No. Okay. Zara. Zara Chaudhary. Hello. Zara, are you there? I think she's not present today. But you know, girls, as I told you before as well, that these classes are very important for you. Even though it is Ramadan, I think this is the time we can easily attend all the classes, isn't it? Is it difficult for you to attend the classes at this hour? I don't think so, girls. You feel like that? Someone speak out. Do you feel that this timing? Yeah, it's not
No,
at all like
Miss.
that. I don't know about your timetable or your routine and all. For me, it's like I wake up around 8 o'clock and then I was doing some work and all that. So the day is kind of long for me. I could manage to have class with you and my household works and reciting Quran, praying, all we can manage. Inshallah, the day is such a long day for us, isn't it? Just imagine we were supposed to have school. We were supposed to have school during the Ramadan time. That could have been much difficult for us to wake up early, get ready to go to the school. We would have been really tired by the time we come home, isn't it, girls? So, Alhamdulillah, the way the situation came out to us, we are fine with it. Right, guys? Okay. So, I'll be closing my class today. Inshallah, next week. And girls, make sure those who did not write down the notes till now, some of you joined very late, like especially Sayyada Samia. You were not there in the previous classes, so I'm not sure whether you wrote the notes or not. Make sure you're writing the notes. If you need help, ask your friends, we'll provide you all the notes. They can just message you and you can write down all the notes in your own copy. Make sure of it first. Okay, guys. Inshallah, next week we'll be having classes. Allah Hafiz. Stay safe and pray for all of us. Okay, guys?
Bye, Miss. Same to you.
Miss.
Assalamu alaikum.
Walaikum assalam.